So there's like two parts of it to this video. One is this announcement and second is differentiation. So for the first part, that before this thing you should like and subscribe, of course. Okay, but from June 1st to till September I won't be active because I need to do preparation for my my October November 2026. So I really won't be uploading that much any videos from my own. Well, if you guys want, okay, then you guys can comment down below which topic you want me to cover next. Okay, if you guys are struggling and or see someone else struggling or your class struggling, then you can obviously comment down below with what should I cover next. Okay, before I reach 200 subscribers, till when I will actually start locking in and cover the from the most simplest topics to the most difficult topics in detail. When I reach 200 subscribers, okay, only 200, I'm very close to it. Now for the second half of the video. Okay, differentiation. I don't know if you love it or hate it, but we are going to do it anyways. It is in the IGCSE syllabus. Okay, so if you are O levels, then yes, you can stay here if you want. Do not worry. If you are at maths and thought this is normal, this is the differentiation for you. No, I have covered a video earlier about explaining differentiation using, I dropped my pen, oh my god, using first principles. So you better watch that video and see how differentiation is done. Okay. So differentiation, how do you do it? They are done by taking derivative. The derivative of a function tells us the slope of the tangent of the curve for a value of x. The notation for a derivative is d over dx, the derivative operator. Now I call it the operator in both of my notes, so I don't really know what on earth this actually is. It is the operation we apply on a function. We apply this into equations. Example, y is equals to a x to the n, we get dy dx. Why do we write here dy dx and over here it's something else? And y is a function of x. This is technically y of x, and this is equals to this. Now differentiating a equation of the form ax to the n, we get this form. Okay, and I will explain it to you what am I even doing. Odd functions, example f of x, you get d f of x, df over dx is equal to 6x. So this is the derivative notation. Next, the gradient. You can find the gradient of the curve at some values of x by 1 differentiating differentiating the equation, and 2 plugging in the desired value of x. It's like really hot in here. I'm losing my mind right now, tired. So yeah, don't mind if I go on just fall off for a moment. Find an example. We want to find the curve of the gradient of the curve y is equals to this at x is equals to 2. What do? You first differentiate this function and then evaluate the output polynomial at x is equals to 2 to get a value. Now, what on earth I did I do? The second equation dy dx is the equation of the tangent. In the syllabus, we only differentiate the terms ax to the n. Remember, you will only have a linear, a quadratic and a cubic given to you. Okay, always. You do not have to worry about other. Well, you can, there is a possibility, but it's definitely not the equation you can graph or solve. Okay, it's only two for fun. Like example, x to the 5. You may be only given to differentiate this and only differentiate it and nothing else. Okay. Now here we can see ax to the b. If we differentiate this, the constant remains and the b is gone because it's a constant and this is gone. The coefficient of x remains. Here the coefficient of x remains again. The constant removes. The coefficient of the x squared, well, x becomes x loses one of its values, and it multiplies the coefficient by 2. So this is not this. Oh my goodness, this is 2ax plus b. My apologies. This is 2ax plus b. It's not that simple. Sorry. Next, if we see the same thing here, but with the here the power drops and this is -1. So you can see the pattern as we stated here above. If we differentiate ax to the n, we get an x to the n minus 1. What happens? The power, we multiply the expression by the power, we drop the power, and we also subtract the power by 1. Nice. Now you may be that kind of person. What happens when n is equals to 1? Well, 1 minus 1 is 0. So if we differentiate ax to the 1, what do you get? A times x is 0, which is this is a 1, and so we get the this. Why do we have a 0? Well, in a constant, the x can be taken as 0. Then if we differentiate, we get what? C 0x to the negative 1, and the 0 makes it a 0. You can think of it like so. I won't really be going as to why it is actually constant, really. Okay, well, you can see it using the slope explanation. Okay, it is in my previous video for the math people, but I also told you guys that you guys can can watch the video up till the power rule, and that's it. Okay, I told you guys, I verbally told you guys the point for IGCSE students to leave off. Okay, for those who are doing 50, 80. Next, stationary points and turning points. What on earth are they? We can easily calculate them by setting the derivative to 0 and then finding the y coordinate at those values of x. Now, a stationary point and a turning point, what are they? They are the same thing, but technically a little different. At the stationary point, it is defined to be when the curve is not changing, when there is no change in the values. Okay, like example, the derivative, because the derivative is defined as a change in x, a change in the function, or a change in x. It is a rate actually. So at these points, at these tips, the function is actually not changing at all. The dy dx is equal to 0. So that is why we call it a stationary point. Have you ever seen a speed time, a distance time graph before? In a d over t, when we say this area, we call this area that the object is at rest. The object is stationary. So this is why I call it a stationary point. It literally has stopped. Why do you call it a turning point? Well, that is because in a velocity time graph or a displacement time graph, only at a displacement time graph, sorry, not velocity, not getting your hopes up high. When we turn at rest. Okay, when we are moving, we move, we slow down. Okay, this is called deceleration. We slow down, then we stop. The point that we stop, our velocity is 0. We are not moving, and then we gradually have negative decelerate further. We start to go back, blah 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 blah. You guys get the idea. Okay, I hope you guys have done your physics before taking this subject. If you're not, then sad, you guys do not understand it. You must do. Physics is good. So we can complete these. So example, we can find the stationary points of the curve y is equal to 3x cubed minus 4x, and of another equation for a quadratic. You can see for a cubic. Okay, in the cubic we have two stationary points. We have two turning points, 2 points at which the graph turns, 2 points at which the object is at rest. And in the quadratic we have only 1 point, the vertex. Okay, the singular vertex. I still name this x1, x2. Yeah, you guys can call it anything, but it's differentiated. And these are coincidentally symmetric, but these will be some other random values. These are for examples. Next is nature of stationary points. How do you know the nature of a point? What does it even mean, the nature of a stationary point? So by nature we mean what kind of point is it? Is it a maximum or a minimum? By maximum it means the maximum value this graph will the graph will go before turning back down. Now obviously this is not the maximum because there are points above it, but we can assume that it is the maximum just because of the stationary point. Okay, call it a maximum also because what if this it is only a cubic. It's like a type of cubic with no other part given, so that's why we call it a maximum or a minimum. Okay, now by nature, okay, a point is called the maximum if it is turning from positive to negative gradient, and a point is called a minimum when it's turning from negative to positive gradient. You guys will see what do I even mean. There are multiple tests, 3 to be exact. So the first method is we're looking at the graph itself. Okay, if we sketch the graph of the function, or if it has been sketched for you, then you can look by saying like, hey, this is the maximum, hey, this is the minimum, hey, this is the minimum. Yes, I use the same damn graph. I'm lazy to change it to other examples, but you guys can see for a quadratic like so, this will be the maximum instead, max value. So the x values are found by drawing a perpendicular to the x-axis and reading the value, like you guys have been doing in graphs of functions. Another method is to use the second derivative of the function, d squared over dx squared. Now why is it not when we do second derivative, you guys will think, yeah, no, it is only this d squared. It's not f, because f is once. It is not f squared. F squared would be double f of f. No. I don't want you to talk about notation. It is that it is a normal thing in notation. The second derivative is denoted by that notation, d squared over dx squared. We do this by first finding the x-coordinate or turning points, then input them into the second derivative. If the output is negative, it's the maximum. If the value of output is positive, it's the minimum. Why on earth are we saying that it's maximum minimum even though it should be opposite? Okay, like, hey, this is negative, so it must be minimum. No, it is the opposite. Weird, but it makes sense. You will get used to it. Now, the fun bit here is you do not need to solve the second derivative. You just got to solve the first derivative and then plug its roots onto the second derivative to find and do this test. This is by far the most easiest test, and I recommend you learn only this test. Okay, you guys can learn the first test also that I showed you with the graphs, but other than that, the third test I have mentioned it, but you guys never need it. You guys will never have to use it. Okay, kind of redundant, but sure. Here I have both examples. Here, this is the maximum. We see the first derivative. It is a root actually. These are the real graphs. And on the second, on the second derivative, we see it is a negative value. So even though they may look nonsense that the sign and does not determine the maximum minimum, it kind of does, but in the opposite sense. It's like society thingy where you think negative is minimum, positive is maximum, blah blah blah. Third method is to see the gradients to the left or the right of a point. We do this by first finding the x-coordinates or turning points. You only need to test one point. As a second point in a cubic, only in a cubic, it will be the latter. Okay, remember, only in a cubic. On the quadratic, it will just obviously tell you that, hey, this is a minimum or maximum. One, we find d over dx of x minus a to the left and x plus a to the right. Y minus a plus a. Now, here I have never mind. No, this is correct. Sorry. And check the signs. 3. If we get left, right at point is maximum, we get left, right. That point is minimum. Okay, what on earth is what is actually going on? This is the derivative test. Okay, and the gradient test. Okay, we do this by seeing the nature. Okay, you know how it's told that from positive to negative and negative to positive earlier? This is literally that thing over here. You see, if it's positive to negative, okay, mathematically. Remember, you will not have the graph. You will not have the graph. It is just for explanation and visuals. But it is to see it mathematically. Here we see it is from positive to negative. And so this makes x2 a maximum point. Okay, remember, maximum can be thought of like a hill. A hill, and a minimum can be thought of as a depression, as a V-shaped valley. This is the max, this is the min, and so this is how you can do it. Enough goofy up. Let's solve some questions. How are you guys doing? A curve has the equation this. Find the coordinates of the two stationary points. So we first find the d. Oh my god. We find dy dx being What? Now we drop the power and minus 1. So this is 3x squared. Negative 2x squared. We drop the power and minus 1. So this is minus 4x. Remember, we multiply by the old power and subtract 1 to get a new power. And plus 5, it's a constant, we remove it. Now, we need to solve for the, we need to find the two stationary points. Meaning we set it to equal to 0. Here we see x is equal to 0 and x is equal to 4 over 3 are the solutions. Now, here it says to find the coordinates and it's a 5 marks. Meaning we need to plug this back into the equation. Y of 0 is equals to zero. Y of 0 is equals to 5. So one of the solutions is 0, 5. Sure. Next, 4 over 3x cubed minus 2. 4 over 3x squared plus 5. We cannot use a calculator. I know not like. Wait. Okay, never mind. 4, 16, 64. We get 103 over 27. I ain't evaluating this all. Sorry. So this is 4 over 3. This. Nice. Next. I have done this in my hard questions video. You guys could check it out maybe. I don't know. You guys want to support the channel. I've done this. Okay, don't worry. You guys can like check it or something. I swear. Why did I even check this? Dude, what huh? Oh my god, I guess I baited myself. Curve has the equation. Let's do this. So at the point this, so we need to find dy dx and plug in 1. So we get negative 9. At 1. Nice. Now turning points. We evaluate the 0 and we get x squared is equals x is equals to plus minus 2. And so we get y is equals to plus minus 8 minus 12 minus plus 12 and 24. And have fun, evaluate this all you want. Okay, so you get 8 plus 8 minus 24, which is negative 16, and negative 8 plus 24, which is positive 16. Voila. At what? 2, negative 2. Final question, and I'm ending the video. Sorry. At the curve as the equation y is equal to x to the n plus qx squared plus 9x. And the derivative is equal to this. Find value of n and value of q. Now, let's reverse this a bit. We know taking the derivative of x to the n gives us nx to the n minus 1 is equals to 3x squared. What? We can see the coefficient should be the same. The power should be the same. N minus 1 is equals to 2, n is equals to 3. N is equals to 3, n is equals to 3. Nice. So n is equals to 3. Next, qx squared is equals to, now derivative of qx squared gives us 2qx is equals to negative 12x. x cancel, 2 to cancel, meaning we get q is equals to negative 6. Wow. Coordinates of the turning point. You guys know what to do, hopefully. And yeah, this is the end of the video. I hope you guys learned something. Goodbye.